All right, I want to go over one of the questions in the textbook. This uses binomial and needs a little bit of trick. So this is number 90 and 91. Use the following information to answer the question. The probability of San Jose Sharks will win any given game is this. Okay, so this is probably winning a game. Blah blah blah. Upcoming monthly schedule contains 12 games. So it feels like they're doing 12 games. So that's fixed number n. And then probability of winning each game is 0.3694. So I'm going to just put down the information here. N is going to be 12 and P is going to be 0.3694. X is the number of games, 1. Okay, fine. Let's look at number 90. I think this is more straightforward. 91 is a little bit trickier. What's the probability that they'll win 6 games in upcoming games? So they will 6 games out of 12. So this is straightforward. Here, if it makes sense to say exactly 6, I mean they just said 6, but if I were to elaborate and say exactly 6 games, it would be exactly the same question. So if that's the case, here I'm using binom PDF. So binom PDF. Again, your n is going to be 12, your p is going to be 0.3694, and your x is going to be 6 games, so that'll be 6. And when you put that all in the calculator, your answer is going to come out to be 0.1476. So, okay. So that's probability of getting winning exactly 6 games. So they're just winning half the times. And there's like about 15% chance that's going to happen. Let's look at number 91. What is the probability that San Jose Sharks win at least 5 games? Here I'm going to highlight at least 5, at least. So this is where things get a little bit more complicated. So here I'm going to write all my values of x. So 1, 2, 3, 4, 5, 6, 7, 8, all the way to 12, right? So that means they could lose every game. 0 wins, 1 win, all the way to 12 wins means they'll win every single game. So out of these, they want at least 5 games. So at least 5 means 5 or up, right? Just like you have to be at least 21 to buy alcohol. That means you can be 21, you can be 22, 21 or higher. So at least 5 is, this part is at least 5. Okay, so it's not exactly 5, but it includes 5, it includes 6, 7, 8, all the way to 12. Unfortunately, I cannot do this straightforward. So what we can do first is I'm looking at 0 to 4 first, because this is like up to 4 games, right? Because we have binomial CDF function key where it calculates probability of winning or getting up to so many successes. So here I could use binom CDF. I'm going to emphasize C here, right? And then we can do n is 12, p is 0.3694, and x is equal to 4. So binom CDF calculates probability of getting up to that many successes. So when you plug in all these numbers, you get 0.5266. Oh, so I see this here, but that's not my final answer yet, because the probability we just calculated, it corresponds to probability of winning up to 4 games. But the original question was asking probability of getting at least 5 successes, which is this portion. So what that means is this red part has about 52.66%. That means this part is the complement, because they have that everything has up to 100%. So in this case, I will do 1 minus 0.5266, so it'll be 0.4734. That will be the blue part probability. So 0.4734. So that will be my final answer. It's part C. Okay. So for binomial random variable. If they ask you for at least something or more than something, we kind of have to do it in 2 steps. If they ask you like up to something, then I could do it like straightforward. Okay, just wanted to go over that.